if I went through this, if I went through that point, I would solve the equation c plus d equals 1. Because at t equal to 1, I'd have c plus d, and it would come out right. If it went through this point, I'd have c plus 2d equal to 2. Because at t equal to 2, I would like to get the answer 2. At the third point, I have c plus 3d, because t is 3, but the answer I'm shooting for is 2 again. So those are my 3 equations. And they don't have a solution. But they've got a best solution. And what do I mean by best solution? So let me take time out to remember what I'm talking about for best solution. So this is my equation, ax equals b. A is this matrix, 1, 1, 1, 1, 2, 3. X is I only have 2 unknowns, c and d. And b is my right-hand side, 1, 2, 3. OK. No solution. I have a 3 by 2 matrix. I do have 2 independent columns. So I do have a basis for the column space. Those 2 columns are independent. They're a basis for the column space. But the column space doesn't include that vector. So best possible in this, what would best possible mean? The way that comes out to linear equations is I want to minimize the sum of these. I'm going to make an error here. I'm going to make an error here. I'm going to make an error there. And I'm going to sum and square and add up those errors. So it's a sum of squares. It's a least squares solution I'm looking for. So those errors are the difference between ax and b. That's what I want to make small. And the way I'm measuring this is a vector, right? This is E1, E2, E3. The ax minus b, this is the E, the error vector. And small means its length, the length of that vector. That's what I'm going to try to minimize. And it's convenient to square. If I make something small, I make this is a never negative quantity, right? The length of that vector. The length will be 0 exactly when I have the 0 vector here. That's exactly the case when I can solve exactly. B is in the column space, all great. But I'm not in that case now. I'm going to have an error vector, E. What's this error vector in my picture? I guess what I'm trying to say is there's 2 pictures of what's going on. There are 2 pictures of what's going on. One picture is in this is the 3 points and the line. And in that picture, what are the 3 errors? The 3 errors are what I miss by in this equation. So it's this little bit here, that vertical distance up to the line. There's 1, there's 1, and there's c plus d, and it's that difference. Here's 2, and here's c plus 2d. So vertically, it's that distance. That little error there is E1. This little error here is E2. This little error coming up is E3. E3. And what's my overall error is E1 squared plus E2 squared plus E3 squared. That's what I'm trying to make small.